Okay, so question 4, it's really telling us that we believe that a strong negative relationship holds in real life between wages and turnover. However, we will increase wages in our firm if we're quite convinced this is indeed the case. To understand this relationship a bit better, we have taken a random sample of companies and we have measured their wages and their workers' turnovers. In the first graph, we plot our sample together with our hypothesis about the relationship between both variables, okay? The relationship of both variables. Which of the following two statements do you agree with and why? Okay? Which of the two statements do you agree with and why? The existence of this sample categorically proves that our hypothesis on the population relationship is wrong. Relation is wrong. Do you agree with that statement or you don't agree? You should strongly disagree with anything that says categorically proves in statistics, okay? This is just a sample. It will never categorically prove anything, okay? So, of course, the existence of this sample categorically proves that our hypothesis on the population relation is wrong, okay? That's the first thing to realize. So this is a statement that you would disagree with, okay? And you almost go as far as saying this is definitely wrong. It doesn't categorically prove anything. Now let's go to the second statement. The existence of this sample suggests but does not prove that our hypothesis on the population relation is wrong. What is that saying? Keep in mind that the red line is hypothesized, is not what we estimated, okay? It's hypothesized, not what we estimated. The one thing to note is that if you notice this red line is always almost above all the observations, right? Almost above all the observations, right? So a more likely regression line would be something like this, okay? So the existence of this sample suggests but does not prove that our hypothesis on the population relationship is wrong. This you could potentially agree with, okay? Note that even if this said something like the existence of this sample suggests but does not prove that our hypothesis on the population relationship is right, could also be a statement that you could have agreed with. Okay? What's the idea here? Well, first of all, you're not sure. Strictly speaking, what this is saying is, would you reject the h naught that the coefficient is equal to the slope of the red line? Well, certainly you're going to come up with a slope that's probably, a bit steeper, likely, okay? Likely to be a bit steeper when I fit these lines here. So the first statement is definitely wrong. The second statement is something that you could agree with, okay? Keep in mind that it does not prove, suggests, but does not prove that our hypothesis on population relationship is wrong. Here's where students get confused with this. They think of this downward sloping line. They look at the sample and they say, but look, we said that higher wages should mean lower turnover. Isn't that what the graph is telling us? Right? So shouldn't I have changed this statement to right? So the existence of this sample suggests but doesn't prove that our hypothesis on the population relationship is right. That could be one way that you thought about it, but really you should have thought about like an hypothesis test, right? And whether that hypothesis test will be rejected or accepted by the data. And every time you run a hypothesis test, all you do is a suggestion. Let's go to part B. We gave our sample to a trainee and asked him to run an OLS regression. Right? So this sample here should look exactly like the sample here. Note this is hypothesized population relationship. This is our OLS regression line. Okay. Which of the following two statements do you agree with and why? Without a doubt, the trainee has made a mistake when handling the data. It's quite likely, but not certain, that the trainee has made a mistake. What do you think? Whenever you see a graph like this, you should think of mechanical properties. Is there any mechanical properties that are being violated on the OLS? Because that's the only way that you can come up with whether the OLS was done correctly or not. What are mechanical properties? Is just a recast of the first order condition. Sum of the error terms should be 0. What's the sum of the residuals there? Positive. Now let's be a bit careful there. Error term belongs to the model, okay? So we shouldn't say that mechanical properties sum of the error terms is 0. We should say sum of the residuals is 0, okay? Notice the difference between the error term and residuals. It is not true that the sum of the residuals is equal to 0. But it is true by mechanical property that the sum, so this is the sum of the error terms, this is not equal to 0, but the sum of the residual is equal to 0 by mechanical property. Okay. So without a doubt, the trainee has made a mistake when handling the data because the sum of the residuals will be positive. And that's not how OLS works. Right? Those are not the mechanics of the OLS. So every time you see a graph like this, where it's asking whether the regression has been done correctly or not, every time you're being asked for mechanical properties. If you look at the video on question 1, you'll also notice that what you're really being tested here is on mechanical properties. Okay? And just be mindful that when you see a graph like this, for example in question 1, your immediate reaction is to think, this is the y variable, this is the x variable. This is the y variable, this is the x variable. But actually what you've been given here is not a y variable and an x variable of the regression. You've been given the residual coming from that regression. Okay, so be mindful of what's on the term as well. Okay?
Sorry.
Yeah.
For the question 3, we have to discuss whether the sum of the error terms is also 0. So, is it true that it is always 0?
No, it's not. So the question is, for question 3, and again, there's a video that's specifically for this question, but for question 3, is it true that the sum of the errors is equal to 0? And the answer is absolutely not. Is it true that the expected value of this sum is equal to 0? The answer would have been yes. But it's not true that the sum of the errors is equal to 0. The sum of the residuals is.
If you think of it like a limit, could it technically be to 0?
Of course. The question is, if you think of this like a limit, like n going to infinity, right? If n were to go to infinity, this sum here would definitely, if the expected value of epsilon is equal to 0, would also go to 0. But for any fixed sample, it will be 0 with probability 0. Okay? It just won't happen. Okay? It just won't happen. So